Welcome. I'm Bill Wake. We're here working on a program for tune similarity. Basically, I want to take a bunch of old-time tunes and decide which ones are the most similar. And we've done a lot of work on the clustering algorithm for that and the display as a dendrogram. There's still more we can do, and Mudshark666 sent me some good ideas on improving the display of that even further, but I think I'm going to set that aside and do some work on the pipeline itself. The way we are now, we have the pipeline is the stages read, transform, and output. If anything changes, we just rerun the whole pipeline. Now, that's generally been fine. I mean, we've been doing this project for, I don't know, months. And but we have this situation with this dendrogram, and let me get it running and show that off a little. With the dendrogram, it has two jobs. One is it's doing a transform. The transform is it's trying to figure out the clustering given the input and then send that result through. But the clustering, this dendrogram that we have, this kind of tree picture, we can select nodes here. That's 5 nodes here, and then we only show those nodes down in the main body. Okay, so it's changing the output because it chooses which nodes to carry through. But the process of getting some input and then deciding what to do, and then the output, well, the input and output happens in one step today. There's a transform step. I give you input, you give me output. We run it through a reduce that just kind of keeps applying it, and then we're done. But that doesn't tell how we get this selection in. And the way we are now is, what we've done is we require that the input is going to give us the same ID on the packet. So our packet, let's bring that up. Okay, so our packet has an ID. The packet is the thing that contains tunes and metadata. Metadata is information about the tunes and about the stages of the process we're applying to it, which we didn't do that yet either. Okay, let's add that to our list. Right to metadata. Okay, so we have our packet that goes through. We detect if the packet has changed or not based on this ID. So every time we create a new packet, we're going to give it a new ID. And yet, some packets shouldn't really be new. If you are transforming and you don't actually do anything, well, you haven't changed anything. You should just send it back as is. And so with the pipeline, when let's say we change our selection, what that does is it triggers a restart of the pipeline. It says, okay, take the input, run it through all the transforms, get the outputs. Okay, but if you run it through from scratch, well, then you reselect the original selection. It erases that out as part of redoing it. Now you want that when it's opening a new file, but if it's the same file, we just want to produce the same, accept the same input or assume it's the same input. All right, and so the change I want to make, let's see, I can bring the pipeline up too. Okay, so here's the pipeline. It creates whatever the source tells it to. It takes that packet, runs it through each transform, and each transform results in a new packet, and it just keeps doing that until it's done, and then consumes the packet. So this is the repeat of cross if you have multiple transforms, and then in the end, the sink consumes it. All right, but that would reset stuff in our cluster view, and we don't want that. So we work around it. Let's see, cluster stage. Okay, yeah, you can see it here. So transform, the bulk of it used to be this, but we have to check that the saved ID has changed. And if it has changed, well, then we're going to recluster and reset the initial selection. But if it hasn't changed, we're just going to go through and return the stuff we always do, which is the selected elements. Okay, so that's the piece that's going to change. And I have a scheme in mind I think will work. Basically, I want to separate out getting input from getting output. And so today we just call transform that does both. We give it the input and then we get the output. But I think I want to change it. And I think what we'll do is we'll make each stage, I think we'll spend a little more memory and make each stage retain the input it has and in the form of the packet, I guess. If the packet hasn't changed, we don't need to do any work like our clustering algorithm. We just send things through. Okay, so what I'll do is I think I want to say I want to turn transform into here's a new input. Now I don't know if I can manage that at the pipeline level or if I have to do it partly in the stage. Yeah, so make all transforms, update the packet ID if needed. Okay, and the problem we have, and we can see this today. Let's put it in quantizing, which changes. It basically eliminates 16th notes and 8th notes and stuff like that, small notes, makes the tunes more similar. The bones of the tune, the sort of core melody is the same. Now, if we cluster, all right, let's select something and let's change to quantizing by 8th notes. Okay. Oh, I thought this would, yeah. Okay. You can see what's happened is it changed the selection down here, 1 and 39. It didn't update the view, but that's the only two that are selected because that's what happens if you reconnect. Now, if you'd had the same ID coming in, we would realize that. And I'm sorry, if you had changed the ID on this one, resulting from this quantized transform, which we should do, this would have updated the display and done that clause that reset the selection and everything. But instead, it's just kind of a mishmash. It acts as if it had only selected two things. I don't think we can. Yeah, we're kind of out of control at this point. Okay, so I think we can do this two-step thing. So I think we're going to say set the input and get the output, and then it's kind of up to the stage whether it does the work on which step. Okay. I want to make this a smooth transition. Okay, and I want to get rid of transform. I think what I'm going to do is say set the input and get the output. Okay, maybe transform can be the output side, but setting the input should mean something. All right, and so I think, let's see what stage looks like. Okay, transform. Okay, it just says you have to have this input method. You have to implement it. Okay, a little bit of a compromise there. All right, stages do this, but transforms, they have a transform function. We want to give them a set input, I think. Okay, and I think we can do that. Well, let's do it as a refactoring. Yeah. Input, well, that's going to be the input packet. And it's not going to produce anything. Okay. So now, I think everything should still run. We haven't touched any. We created a new function that nobody calls. Yeah, we'll get there. Okay, just get rid of the warning. All right. Was that the only one? Yeah. Okay. Okay, so nobody minds that at this point, but I can make my pipeline do some work with it. Okay, so what I'd like to do, I think I want to say transform.set input to packet. Okay. So, yeah, neither can I. Okay. So we're saying you're going to tell the transform the current input and then transform it, return that transform. Okay. So that should be okay. Again, everybody's calling this empty function, but now I've got things in place. I can peel off stuff one at a time and make it so that the input is saved. Okay. So now let's override that input function. Okay. And what I'm saying is I want the stuff that happens on the input. Okay. If the saved ID is equal to the selected ID, we're doing the transform, the filtering. If it's not, oops. If it's not, we're going to, okay. Yeah, if it's not the same as the existing input, we're going to save it. We're going to set the proximity matrix and set initial selection. Let's go there. If cluster is not nil, I don't know. That strikes me as, I think there's something going wrong in here. If the cluster is not nil, then we start out empty, right? If the cluster is nil, well, I don't know why it wouldn't. Why it would be. Cluster starts out nil. Okay. Element starts out empty. Right. Okay. I don't know what the complaint is here. All right. If we don't that saved ID, we build the matrix, we set the cluster, and we set the initial selection. Okay. The result of clustered. Okay. If the cluster worked, we're going to set those elements. Okay. But the thing we haven't done, I want to keep the input around. Okay. So let's save the input as well as the ID. Okay, so I'm going to say current input equals input. Current input doesn't exist. All right. We're not publishing it. His type is packet. Okay, now, is that set initially? So I hate these initial setups. Yeah. Okay. Well, let's give it an empty packet. Is that doable? Yeah. Okay, we'll have to give it empty. Okay, so we're just setting the initial setup. We save that input. they get a default generated one, so it'll be guaranteed different. Okay. Oops, cluster stage. Okay, so now I have this current input. I want to use that here. Okay, and I don't think I'm using there. Okay, so is this convert to expected type string? Metadata is string. Okay. All right. Oh dear. Okay. Oh, yeah. Now these guys are not, they're not calling that two-step thing. Okay, so we're going to have to make them do that. Okay, so stage dot set input to this. Student packet, right. Okay, I think. All right, let's try that again. Oops, missed one. Yes, thank you. Now, build failed. Did it there, but not there. Okay, so give stage a set input method, make cluster stage retain that input. Okay. Slow net here. Okay. All right. So I think that's what I want here. All right. So when somebody comes through and they say set the input, if the saved ID is different, we're going to change all this stuff. And when they do the transform, that'll do that. Okay, so I think what I need to do then is I don't want input coming in here. I want it being held by the whoever got called with this. Let's see, is this helping anything? Okay. Maybe I need to do quantize to see it well enough. Initial selection is going to find that last element. Okay. And okay, if the saved ID is equal, we set the input and it's equal to what it was before. Well, we are just going to not do any work at that point. Okay, so I guess my hope is I don't know if I want to make them hold it per se, but like I would like this stuff to be outside. I'd like the pipeline to own this part of the problem. I don't think I can do that until I get everybody switched over, though. Even this. Yeah, I just don't know. All right. But at least we've done that much. All right, now let's get quantized stage. Maybe I should just do all the stages. I don't know. All right, but I'm going to put in a function override set input. Okay. Now, what's the transform still? I believe we got that. So I'm using current input, but input, I don't know why it didn't complain about it. I guess I've already got it as an anonymous or a underscore argument, so it's not seeing a problem with not using it. Okay. In the return statement. Oh, you're right. Yeah, how are we modifying that? No. Let's close that. He is getting a new ID. Right. Okay, so that we're saying this should be current input. Okay. Okay. Let's go on to this one. Now, he's modified the tunes. What does this mean? Sorry, packet. It takes the tunes, which are modified, and then it appends the metadata. So, okay. A little awkward, but okay. So, packet. Well, I'm going to name this to input for consistency with our other usage. Okay. So here's input. All right. Let's make a new field. The current input is of type packet. The other way to do it is to make it optional. Actually, the other way to do it is like this. We're saying, don't worry, I promise it will be there. All right. And we're going to say current input equals input. Okay, so in this one, we're not doing anything, and I'm just trying to get it moved over to the new style. It's using current input, and then down here we'll use it. And here. Okay. I think that should be neutral to it. Well, okay. Yeah. So the thing is, we're taking something transform that says, do me in one step and I'll do it all. I'll take the input to the output. And we're saying, no, we wanted to split that up. So it's a set input and a transform. Well, I can tell you this test is not going to have a set input on that packet. Okay, so maybe I should do like the other one. Yeah. I find this awkward. I'm forcing myself to do that. I don't know. Is it any better up here like this? Yeah, maybe I'm going to try. I don't know. I'm tempted to pull it up here. I'll make this. Okay, so if I do that, then cluster stage doesn't need to declare it. And quantizer stage doesn't need to declare it. Gosh, I don't know. Yeah, you can initialize where you define it. It's an awkward initialization, which is maybe a different problem. Do I still transform? Okay. Like this is awkward. Empty stuff in there, but I'm doing it once. Okay. But on the other hand, I'm pushing stuff up into the parent classes, and that's a little marginal. The other thing I was saying was I turned something from transform, which is a one-step do-it-all process, to saying now you should call set input and then you should call transform. And you can do it wrong because we still have input here. And that's kind of what's happened here. This transform does not have a set input, and it really should. It's not meaningful to call transform without an input defined. So I should say transform dot set input to packet. Okay, now eventually transform is going to take this away, and it's going to be the only way to get data in is to use that. Okay, so this may not be the only test that fails because of this on quantizer, but we're going to have to do something like this on multiple tests, maybe. No? Oh, this one's pretty simple. Okay. All right. So is quantizer satisfactory? Well, he gets his input. Nobody's using it. Okay, so make quantizer stage support set input. Yeah. Well, you can't define variables in extensions, but the rest of it may be. I think when the packet goes away from the packet no longer takes input. I'm sorry, the transform method no longer takes input, and is forced to rely on whatever it has. That would push anybody to use a current, a set input when they need it. So I don't think that's terribly bad. Okay. I think, yeah, I mean, it prevents, well, if somebody doesn't call set input, they get empty stuff. That'd be a little confusing, but the reality is everybody's going to call set input to do anything, I think. We'll see. All right. Who else is a transform? Let's go find them. Okay, so transform. I forget what it'll show me. Can it find, well, no call. I guess that will do. Okay, we got cluster stage, we got filter stage. Okay, and well, that's going to look a lot alike. Okay, where's cluster stage? Quantizer stage. This seems like that's a parent function. Let's do that. I'll put this over here. Okay, I'm going to move this. Well, I'm going to replace this. He's not an override. This should probably be public. Okay, let's see how that does. Filter stage doesn't need this. Now, I think our clustering algorithm that's going to have to use that. All right. It may call the super to do the storing, but it's got its other stuff it wants to do. All right. Now here, transform. We don't want to use packet. We want to use input. Current input. Okay. Okay, and I'm just going to muck with the name. Whoops. Okay, let's not mess with the name. I guess this is going to be our same problem. We call it stage. Let's make sure these all take that. Basically, before any transform. Still these cluster stage filter pipeline tests. No, that's the only other one. Okay. He's using packet. We want to use current input. Even though he's really not doing anything. He's just a test junk one. All right. There may be some tests that, pipeline tests that needed this. No? Okay. All right. Okay. Now, I believe everybody's got that out of their system. So now I'm going to take input away. So transform no longer has this. That should break build. It's funny they don't. How it opens thinks the wrong. I've got the thing in the other tab already, and it thinks I should put them over there. Okay, so there's filter stage, quantizer stage. Pipeline. That's the caller for them all. Okay, yeah, all our tests. Okay, build again. Okay, so here's, oh, it's a preview. So let's do stage set input of packet and take it out of there. Hey, welcome. Yeah, this is Swift. I'm working on this program that's, I'm taking music in with what's called ABC notation, and I'm trying to decide which tunes are similar in a group of tunes. So let me get things back running again, and I'll do a quick demo. I'd usually do that for new people. All right. Transform back. Right now we have a pipeline that we use and we're trying to refactor that. We're going to make it work a little differently. So I think I got the, whoops, there's one. All right, so remove transforms argument. Okay. Well, we're kind of in the middle of a good sized project, so you'll at least see it in action. Okay, so here we have this. We open up a file. What I've got is, this is 39 versions of Nos Galan, which is the sort of old Welsh version of Deck the Halls. And what this view is, we take the melody of the song. It's dun 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 dun. You know, it's kind of bouncing up and down. Okay, and so we're just getting the overall shape of some songs. And what we've been working on lately is this notion of clustering. And we basically make a big graph that compares every pair of songs and decides which two are the closest. And then, like, these two were almost identical, or maybe were identical, so they have got a very close bar. And then these two are close, and these, you know, this section is pretty close between these two, and so on. So this stuff is selection, okay? And so down here you get the ones that you selected. And I notice in passing that most of these ones that came up very similar have pretty similar titles. And most of the Nos Galans or Nos Calan or whatever's, it sort of reflects that they are basically the same tune, and some of these others are more variations further away. All right. So the way it works right now, let's get the pipeline. Okay. We'll see a little functional stuff, but basically my stages are either inputs, transformations, or outputs. And our process is get a packet from an input, and the packet has a list of tunes. And then we basically tell each transform, each stage, set your input to the packet, and then do your work, do the transform. That results in a new packet, and we keep pumping that through the pipeline until we've gone through all the transform stages, and then we finally give it to a sync. All right, and now this is the part we're trying to work with, and I'm kind of feeling my way through it, honestly. I think I have a scheme that will do what I want. But one of the challenges is if you change the input, well, every time you change the input, we're going to reset things. And so it resets the selection and stuff. But if I have a filter in the middle, so let's say I quantize by quarter notes, if I change this to quantize by half notes, well, sorry, I did that too quick. Let's select something. If I quantize by quarter notes now, it should reset the selection. Okay, and it did, but the view is not current. So I think there may be more than one thing going wrong here, but I think the fact is that this thing, it's because every time we change something, we go back and rerun the whole pipeline. And this thing doesn't realize like, oh, you just changed the selection, but you didn't really change my input, and that's tricky because we've got to define what that means. I don't know. It's maybe I'm off on that. Okay. So if you read a new input file, that we get a new input, and we have an ID on there on the packet. It's a UUID. So every time you generate one, it gets a new input. Now, when somebody sends it through, I mean, if they haven't changed anything, what should happen? Well, I guess it depends on their input, right? Well, this is going to be interesting. So if I change it, it should say I'm a new thing. But in a way, we'd like it to not say that. So I'm a little... Because the selection should be valid. But no, let's take another. If it was a filter and we said, give me only the ones that had Joe in them, all right, and edited that to say Joe, then we do have to reset. So I guess every change in his values should generate a new packet. So I don't know where that's leaving me. If he changes, he should reset his selection. Yeah, you're absolutely right. Clustering will potentially change. I don't know if it will in these. But let's make it whole notes. That's it. Well, it won't on these because they're just not that similar. But you're right. They definitely could. So if the clustering is going to change, we certainly need to redraw. And if the clustering has changed, our selection is no longer valid. It's just the same tunes may be coming through, but even that's not necessarily true. Okay, so I guess the reason I'm struggling, a reason I'm struggling, is this: we don't want to do clustering unnecessarily, and we don't want to leave the wrong selection lying around, and we don't want to reset the selection if we don't know. Gosh, I don't know. Oh, spent 2 years learning C#. I just say take some simple app. I'll tell you, I've there's a site, Hacking with Swift, Paul Hudson's site. He's got great videos, great kind of stuff there. He's got something called 100 Days of Swift. I haven't done it, but a lot of people seem to be raving about it and going through it. Basically, it's a challenge per day kind of thing. Now whether you want to go to that level, I mean, you got some background with C Sharp. There's a lot of similarity, but the more Swift UI stuff is totally unrelated to C Sharp. But yeah. So yeah, I don't know. I mean, if I'm not a good one for advice on this stuff, probably, but I do. The two resources I do are Hacking with Swift and then Ray Wenderlich. See if I can get those things up here. I forget the deal here, but I think it's maybe it's a $15 a month kind of thing, and you get a bunch. They have bunches of videos on. Well, I use the iOS Swift. They do have Kotlin and Flutter and Dart as well. But they've got a bunch of decent videos, some great videos, and lots of topics covered. Oh yeah, they changed their name to Codeco, Kodeco, and then Hacking with Swift. This site seems to have a little bit more freely available videos. He also has books and online courses and stuff like that you can do. But either of those, I would try. The other one, Exorcism, is it Exorcism? Yeah, this one. These folks have bunches of problems kind of set up for you. They tend to be more small and mathematical. Let's see what this Swift looks like. Oh, I have to sign up to see it. Yeah. Okay. My recollection is it's a lot of smallish, kind of one-page problems. There may be more there that I'm not as familiar with, but even just looking at these, right, these all sound like basic language type things. If you're familiar with C Sharp, 90% of the stuff they're showing here is not going to be any different. They do have this guard stuff on if statements and higher order functions. That's probably a little different, but the basic stuff is the same. Yeah, most of the rest of this is conceptually the same. You might have to look up the details. So I don't know about that one, but the real thing I say is just, make up a small project and do it, and do that about 10 times. You'll be a lot farther along. Kind of do something end to end. I don't know what the world's looking for in the Swift market to get a job. I mean, I think the way to do it is to go try and do it kind of thing, see what kind of feedback you're getting from them. Some people give you informational interviews, just kind of help you assess your skill level and all that with no job implied or anything like that. I'd give some of those a shot, but, just do some problem, work your way through it all the way to the end and see. Yeah. For me, there's these two user interface kits, basically. UI Kit's the older one. I find it a lot more work to get hooked up to and understanding, and Swift UI is the modern one. But the reality is a lot of people, real projects, are using UI Kit. So, there may be ones that are only looking for UI Kit. It's not like you can't do it. It's just my lazy nature likes the Swift UI better. I've been switched over to that a couple years back and have been happy enough. It doesn't do everything UI Kit does. There's a way to wrap UI Kit components so you can call them from Swift UI and vice versa. So, I don't know, but yeah. So, all right. So on this, back to it. All right. So I think you've convinced me. Yes, if quantize changes, that could change the clustering completely. You should redraw. Okay. And if somebody, I guess the case is if somebody's sending the same output that they always did, right? Yeah. So I think the thing is, if the pipeline, if the if the input file doesn't change and the filtering or the parameters don't change, I think it should put out the same ID, and that's the thing it's not doing. Now, the thing, this packet thing is going to be in the way on that. Okay, let me close this side. Okay, so this, what I think I'm pushing to is the packet here. We need to decide if we're going to keep the same ID or not. This one is, it's creating a new packet from the old packet, and thus it's getting a new ID. Okay. Let's see, struct versus class. Well, they're somewhat related. I mean, they both hold fields and they both hold methods. The real structs are kind of by nature tend to be more towards immutable things. But there's even some workarounds for that. But yeah, start with struct, and then if you start needing inheritance, well, even that you can inherit some stuff. It's really a question of identity is kind of how I think of the difference, that a struct is a value intended to be a value object. If you're just familiar with that distinction of value versus reference objects, that in some sense the contents of the struct are what determine whether it's the same as another one. And so if this was representing numbers, you'd like the numbers to all be treated the same if they have the same value. But if it was classes, they get a separate, two separate instances are not automatically the same. So, all right, well, good luck for you. Okay. Yeah. So I think the thing is, if you're reading something from the same input, and if you're producing the same output, you should produce the same packet ID. But if you've changed things like this, well, it's not a real number, but then that does change the cluster, and you should change your packet your output number. Okay. Now, so this says definitely change my packet number and change my result. Now maybe I should let's look at quantize. Okay. Whoops. Okay. So all right, he's got his current input. Yeah, like somewhere this quantizer, let's see who calls this. Okay, it's the stage. Okay, who changes these? It's got to be the view, right? So here's this view. Yeah, well, I think the thing is he should create new output if he's changed his numerator or denominator. But if he's got the same input and he hasn't changed his stuff, I think he should be producing the same output. So like what I want to happen, I don't know. It's like we did the saved ID before. Maybe I got to do that same thing again. That was in cluster stage. Yeah, I need to change the UID if the numbers change. So this one, right, I did the saved ID. Well, I was relying on him to change the new one. Yeah. I think there's somewhat the same problem here. If he's got his current input and he hasn't changed his selection, he shouldn't change his output. All right. Now, I think it's easier to deal with in here, so maybe this is the place to do it. But if so maybe this should include the ID. I mean, what I expect to happen is if his input has changed, and maybe this is just too complicated, but if his input has changed, so if set input is called, he needs to change the output. That should be a new packet because it's applying the quantize function. Now, it could be like if I quantize by 64th notes and everything was already 64th notes, it's irrelevant. Quantize should never return current input. I think it's, current input. It will never return current input. It'll return a new packet with new tunes based on current input. And I don't know, all this constructor is doing is really putting in the tunes you say in the metadata. It's merging the metadata string in with the current metadata. I don't know if that's enough. Okay. Yeah. So I got to get three cases in my mind. One is if your input hasn't changed and your settings haven't changed, then I would really like you to put out the same packet, including ID. If your input has changed or your packet or your numeric settings have changed, then it's a new result and it should get a new ID. And this code doesn't distinguish those two cases. So I'm skeptical of that. Now, how to distinguish those? I think I got to do more with this, and I'm kind of dreading that too. If yeah, it needs to remember it at least. Well, yeah, maybe calculated packet is the concept we should be after. I mean, no, because if they change the numbers, set input is not going to change, right? So, okay. I think, well, I think more needs to happen when you change these things. They should trigger a change in like a saved ID kind of thing. So let me go in this one. Tunes, new metadata. Okay, he's using append. Right. Okay, in here. So I think what I want is, well, okay, the current state is if your input hasn't changed, we come through, sorry, if your input has changed, we come through and map a new thing. If your input hasn't changed, we still come through and produce a new ID, and that is wrong. If nothing has changed, I guess. If something has changed, I definitely want to reset that saved ID. I want to give this thing a saved ID, and I want the packet to use it. Maybe that's the tricky part. Is that... Yeah, you definitely could calculate it at that point. The sequence, it's going to be like they call set input and we do transform, and that's sort of the right away thing. Now, somebody could change these settings and then that triggers the pipeline to rerun. All right. And but if the settings are changed, we want to produce a new output. So only transform is called after the numerator or denominator changes. Set input, well, the way we're doing it, it is called. But yeah, we want to make it so it doesn't matter. Right. So one thing I think should happen, I don't know, maybe get some of these out. If there should be a saved ID that is your input, and if that hasn't changed, then your input hasn't changed. Okay, but these numerator denominator, they should force that thing to change, and then when you call saved input, set input, we know it's a change. We know that it needs to recalculate and get a new result. But if they're not changed, it doesn't have to touch them. All right. And next step needs a result from the quantizer. Yeah. Okay. So let's see. The way we are now, we are always producing a new packet with new output. All right, and that's at least the safest thing to do, I guess. All right, but where I'm going, let's get this saved ID thing going and see. Okay, I got a var. Saved ID is a UUID. Well, let's just make one. Okay, so I start off with whatever it is. All right, when you call set input, now can this live, do I need to own this? This is the thing I think can live up in the parent. Maybe I should do it and then push it to the parent, I guess. All right, but I get the saved ID. Now in set input, yeah, I'm still not changing anything. I'm trying to keep track in my head of, am I refactoring things? I think I still am at this point. Let's override function set input. Yeah, the input packet has the UUID in it. Okay, must, right? Okay. So if, well, I'm going to do this. If saved ID equals input ID, Well, I'll say not equal. Then I'm going to call super.setInput input. Okay, so I'm only calling setInput if it's new. Yeah. They may turn out to be the same. Okay, what if I do this? If the stage ID is not the same as the input, okay, like it is, that's the first time through, we call setInput, which stores the current input. And now we're saving the ID as well. Okay. And the output, now this is where I need to start testing if I'm going to do anything. So this should hurt nothing. Funny because one tool doesn't like what the other tool does. Okay. Yeah. All right. So let's add saved ID to quantizer stage. Okay. Yeah, I think I can do everything in super with this. I'm going to do it once in quantizer and then we'll push it up. All right. So let's get the quantizer tests. Transform quantizer. Not sure which. Why do I have two quantizers? Oh, that's a pipeline. This is the one we want. Okay. So all right. So quantize with new input returns new packet ID. I think that that's something. I really don't care about the actual manipulation. All right, so quantizer. Well, where's it forming its input? Quantizer map. Okay. Well, sorry, is this working with the quantizer stage? It's not. Okay. Maybe it was that other. You know, you're right. Let me open the file so I remember quantizer transform tests, add settings to packet output. That sounds more like what we're doing. All right. Yeah, let's take a break. 3 or 4 minutes and we'll come back and add a test to see if we can detect this saved ID updating correctly. Okay, welcome back. All right. I think I'm going to back up a little. Can we do all this in super? Yeah, I think maybe we can and should. So we have stage. I'd like to deal with this in here. All right, let's move this up from quantizer then. Okay, modifier order. Well, I don't even know if I need any of this yet. Nothing uses it, so. All right, let's take that out. Okay. And, yep. Okay, so pipeline tests, I think, is the right place to test this. Yeah, it's got that test source and test sink and all that stuff. So there, I don't think there's a stage test per se. No. Okay. But I think they all kind of fit. Right. So, well, we'll just take this as an example. Okay. So the goal of this is I want a saved ID in the parent. I want to know how I can tell. All right, we'll create a source and a sink and a transform. Okay, I don't care about these. Okay, transform, source, and sink. Now, if, let's go to pipeline. All right, so there's process. If right, well, if I call process, should its output be the same as its input? Something like that. If you pass an input in, I guess that's the first time you call process and it's going to pass this packet around and then we consume it. We should see the same packet ID. Okay. I guess that depends how our tests work, how our test transforms work and stuff. Create. Okay. Let's see, what does transform do? And he returns this packet. Okay. I mean, if you're adding metadata, you're transforming it, I guess. Okay. Well, here's my test. pipeline. Let's say something about stages. Stages, change packet ID if they change. Something like that. All right. So if I call this choose okay, that sets up the stages. But if I call process, okay, I'm going to take the transform out. Let's start easy. Okay, so we process, and then, okay, I think that's all kind of set up. Let's make the sync. Let's make it also track the packet. Well, last packet of type packet optional. Okay, so it sets the output and it saves the packet. Okay. Now creates a new packet. I don't know. This may be the wrong place to test this too. Oh, golly. Okay. I think this is this a packet problem or a transform stage problem? Yeah. So, okay, let me run it through. So what I want to do is pipeline.process twice. And then I want to capture sync1.saved ID. And then well, okay. I'd like to assert ID1 equals ID2. This is assuming they don't produce different stuff, that the source produces the same thing each time unless it's told to change it. But I think these test packages, they're more for testing the pipeline doing its thing than they are me doing what I want. So I feel like I maybe need to do a separate test for them. Even like a separate test class, basically. And I think yeah. All right. Well, I think change packet ID if they change. Okay. Yeah, I mean, I guess I'm asserting not equal if they change. Now, do I want to muck with test source enough to do this? I don't mind giving these guys some side effects and stuff like that. Yeah, let's try that, I guess. Okay, so let's make a packet equals this. Okay, if I do that and then return packet, return packet, that shouldn't, oh, I'm going to break. Two sources. I was going to do one that forces a change. So, okay. Okay. So let's make sure this is okay. So I'm kind of adding things to change the way they work a bit, but I think that's okay. All right. And then I'm going to give this a test method that says force new packet. And that's only for the test class, which I'll put it here. And then I'll do this. Okay, just to do that. Okay. So in oh, okay. So in the test, I'm going to create the source. I'm going to, well, let's make sure the old tests don't break. All right. Good. Okay, whatever. All right. So now I have a test source will produce a packet and only produce a new packet if you tell it to. Okay, which to me is sort of like if somebody did the open button on the thing, then it would have a new packet in there. All right, now do these, choose the transforms. Okay, they're not running multiple pipelines. Yeah, they're choosing, okay. Yeah, so let me try this one. All right. And I'm going to do sync. I'm going to make him retain that last packet. Okay. Again, should not break anything. Oh, that's with my tests, new tests. Okay. Okay, is that... Okay, now I think I have what I want for a test. Source one, sink one, and a pipeline with no transforms. We tell the pipeline to process, and we capture whatever packet ID it has in the sink. And then we tell it to force a new packet, and then we rerun the process, and we get the last packet in the sink. Okay, the ID. And these two things should not be equal because the forced new packet should have forced a new ID on them. All right, I think stages, well, let's see. Send same packet ID if they do not change. Okay. Well, no, that's not what I did. Change packet ID if they change. Okay, that is what I'm doing. All right. So I think, well, I think I'm testing my test cases, my test stages. Okay, that does its thing. If I didn't do the force, it would not. Right, so, but I'm not testing my real stages with this. Well, I don't test transform with it yet. Maybe that's okay. Okay, and let's test the flip side. They don't change. Oh, I should change the test too. All right, take this out. Right, and oh, this should be assert equal. Okay. Okay, so I have something going right that if the input packet doesn't change because they read a new one, then the sink sees the same packet, and that is a good true thing. Now, if a transform does something, all right. So if I guess what I'm saying is if a transform gets the same input and has the same settings, He should produce the same output. Okay. Let's see if I can express this. And this is probably the harder one. Okay, and then I do want to transform now. Yeah. Transform. Okay, so this one is processing the same source packet. Okay, because transform source one gives the same packet if we don't force it to change. And we would like to see that transform the two transforms with unchanged stuff should stay the same ID. Okay, and this is going to fail, I think. At least, hopefully, because that'll give us some chance to make some progress. Oh, man. Okay. Why is that passing? Sync one. Oh, what does he do? What's his transform? Transform. How is that passing? Pipeline process. Oh, was he doing nothing based on current input, maybe? I don't know. He's creating a brand new packet. So how is that showing up the same? All right, well, assert equal. Super for the transform, yeah. Because super is just a subclass responsibility kind of thing. So this test transform creates a new packet. So it gets an ID. Every new packet generates one. So it should have an ID. I think we need to change that, but that's the way it is now. All right, I'm going to run it to here. Okay, so let's print sync one last packet. Okay, 0B2. All right, now I want to break on the transform call. We'll continue. Did I do something funny? Okay, I should stop here. Heat for B44. Okay. Now pipeline.process should take me to. I should run transform here. Okay, where's pipeline? Process. I didn't choose my transform. This just creates the list of available transforms. I have to actually choose it if I want to get it in the pipeline. Okay. Now I'm sure this test should fail like we want, or as we want. Okay, let's get that. Good. Okay, I feel better. It's hard to get them right sometimes. Okay, so this. Well, that does seem like it's a little redundant, but okay, so this does fail because we call get input and we're just overriding and then transform produces a new packet. Okay. I'm not sure how the interaction should be here, but so somehow I want a saved ID to change this, but I think we have to take a responsibility. I think in our transform, we're responsible for setting the ID of the result. And I don't think we can get around that. We can save it. I mean, we need to save it. Yeah. The saved ID I want is the input. And it's like, I got to do something if I want that to affect it, right? So, all right, let's give this saved ID. Okay, we start off with an ID. If keep not doing the not. All right, if the saved ID has changed, well, then our input has changed. And our saved ID is current input.id. Okay. So now we need to. Yeah, I'm trying to implement that now. If transform doesn't change, it should stay the same. Yeah, so I think, I guess it's like, what's the output ID, right? It's not going to be the input ID, but if the input ID changes, the output ID needs to change. And if the input ID is the same, the output ID should be the same unless we've changed something kind of spontaneously. Okay. But I don't think I can enforce that here on set input. I mean, in our cluster one, like I do think he needs to override this. He probably should be calling his parent. Yeah, that's not good at this point, but I don't know if it'll catch the right ones. No. Okay. It's going to rename it manually because the tool doesn't want to. Right. Okay. Right. Yeah. Because I don't need the. I mean, I'm detecting the change in input because of that, and I could certainly check current ID versus saved ID. I mean, current input ID versus input ID. But somehow I need to. Well, the dendrogram is not really passed through though, because it changes the selection. So the dendrogram, the ID should stay the same unless the input changes. I think if you change the selection, it should change its ID. Maybe saved ID is really output ID. Maybe that's the way I got to think of it. Output ID is UUID. Okay. Maybe this is more like it. All right. What output ID should I use for my transform? I'm going to start with one. When you change the input, I'm going to generate a new one. All right. So anytime I'm definitely going to change, I need to do this. Now, it doesn't say anything about my numerator and denominator. They need to do this same sort of thing. All right. And now when I generate the packet, my packet should use the output ID. Okay. And I think that, okay. So that's a responsibility on each stage to use an ID that generates it. I don't know. I'm liking this thing less and less, but it seems like an awful lot of work to avoid changing this metadata thing. Okay, but so I guess what I'm saying is metadata. Okay, I gotta look up a Swift thing. Swift, whoops. Swift array. I think, did you tell me the other day we had a plus on array that would generate a new array? Or was that set? Let's find plus. Yeah. Okay. Create a new collection by concatenating elements. All right. So I think I can do that. Let's rewrite this. Copy apply to string. That's really too bad. I mean, I can turn it into an array, but that seems like a waste. Plus other, create a new collection by the elements of a sequence and a collection. All right, let me do it this silly way. I mean, the compiler can eliminate the work of this, so it's probably not as bad as I'm afraid. These things aren't that big. Okay. I know. It's hard to keep it straight. Yeah, lots of them, I don't know. It's not uncommon to have a plus that takes an element and know that the type is compatible. This one only seems to want sequences of some sort. Wrap it in an array is fine. All right, now I think I have, let me ignore this one briefly. Disable. Okay. I want to make sure that change is neutral to everybody else. Okay. Stage back. Okay. That, and I'll just check. Well, okay. Make packet append arrays to get new metadata, and we got steps toward pipeline knowing its saved ID. Okay. Okay. Now, what this is just copying this. I think this is a waste. That's not that hard. All right, but the real thing is ID of UUID equals UUID. Can I do that? Property ID requires. Oops. Okay. Return from initializer. Okay. Well, no, I don't. This is what I don't want. Okay. No. Oh, whoops. Okay. Let packet take an ID. All right. Now, I want to first get rid of this. And then I'm going to make this ID required in the end. Okay, so let's get rid of these. This should be mostly the stages creating new packets, I think. Okay, so he returns packet like that. I want him to return metadata is current input dot metadata plus that. All right. I think he's just not with the times here. Okay, filter stage. Okay. Okay, I think I messed up one. Array of string to expected type string. I think he's still. Oh, sorry. Dot metadata. Dot metadata. Yeah, I think they're confused because I'm changing constructor calls. I'm trying to get to this one. Oh, this is string. Oh. Okay, I'm going to duplicate for a moment just to try and keep things closer to green here. Yeah, we did take this out. I'm surprised that warning hasn't popped up today. Okay. Good. Okay, so make packet allow ID, make callers provide metadata and remove use of one packet initializer. Actually, I'm hoping I did. All right. I don't think anybody's calling this anymore. And then the callers of this one, I think I'll just make the metadata with array of strings the default canonical one. I feel like that may be where I started some months back. I guess I could be looking at these. Do they really need the metadata? No. All right, let's go back to packet. No one's looking at this metadata. Stage.cluster. Yeah. I got to make sure my real ones do use it. But I guess we should have a test for that somewhere. Okay, yeah, so that one's got to be there. But these tests, put transform. Yeah, that doesn't matter. Yeah, the bad thing with that is doing this is helpful to the tests, but slightly risky to the real code, I guess, that I could omit it and not notice it. I don't think that's going to happen, but okay. Did I get these? I guess I did. I'm looking at the metadata there. Test source, maybe possibly helpful for the data there. Now this one may have a problem because I'm not appending metadata always. Transform does. Sync doesn't produce a packet. Okay, let's check these. I probably should do the same thing for tunes, default it to an empty list as well. I know I've got a few places where we do that. Statistics stage, we're getting there. Okay. Hopefully nobody's using this one. Should all pass. All right. Simplify packet to always take array of string for metadata. All right. Now, where's our pipeline tests? Okay. Back to the bottom. This test is ignored. We don't want to do that anymore. Okay. Now, this test should still fail. Okay. Pipeline process ID. All right, now we got to look at the process of producing the packet. Okay. I think the contract we're saying is the packet should write the ID. What do we call it? Stage last output ID. Okay. Now I think this should pass, but notice it's also a test of our test class. Okay. And then I think we want the converse. Okay, and we're doing that force like we did before, wherever that is here. And the reason for 2 is the source sync tests are actually, they are a little different than the transform tests. So this should, about assert not equal, this should pass based on what we have now. All right. Okay, and so I want to say that a stage well, I really want to say you ought to be providing IDs on your packets, right? Let's take this off. I'm willing to let the tests have it, but I don't want my stages having it. Okay, so by default, he should be using output ID. Cluster stage, yes. Dendrograms, whoops. Keeps erasing them before I. Well, this is the preview. I guess I'm okay with that. ID, UUID. Okay, because previews don't care really. Now this one, right? He's, well, the way it works now, this was UUID. I'm not quite sure. We haven't walked through him to make sure he's doing everything right. But okay, transform, build your text. No. Manual input stage. Yes, that's correct. Preview. This one. Okay. Let's see where we are. Yeah, okay. All right, now these are all tests. I think I'm okay. Okay, so we make production classes explicitly declare the UUID using output ID in the case of transformations. Okay, now Well, we kind of have the basics. So I guess what I'd say we have now is if you're getting input, well, if you got the source feeding you and you get the same input and you don't change anything, you'll get the same output packet ID consistently. But I don't think I think we need to check. I'm going to close everything here and let's get to file input stage and make sure we believe it's doing that right. Okay, so it defaults to an empty packet. When you call make packet from input, it generates a new packet. All right, now the question is, input. Where's input being set? Create packet. Okay. Yeah, so this is triggered by the actual URL editing changes, end up calling handle result, and it calls make packet. Okay, just so it doesn't do it in line. Make packet on the body. Okay. And that's after reading a file. So that's coming from the output dialog. Okay, so assuming you do that, you get that packet back. Okay, I think that one's okay. And then the other was manual input stage. I'm less convinced that one's right. If where's your input? It's on your source. Okay. Yeah, where's that being used on that file input? I think he's setting it when you read it. No. Input equals body. Okay, so in this case, it only happens. So for manual input, if somebody changes input, okay, we'll do a quick run, just see where we are. What I think is going to be the case is that file input is going to be done right and manual input is going to be wrong. Okay, so we'll take the smaller one. All right, and we put a cluster. Okay, now. Now that should be okay. Let's turn off cluster. Let's put quantize in and then cluster. All right, that reset. We change this. This should be new. Oh, that's not working either. Yeah, so we are only dealing with file changes. Okay, but that stayed the same. Okay, so that's something. But the file, that should change this. And did not. Okay, so something's not quite there. And then let's take manual input. Okay, yeah, forget even what you need. You need a X number, you need a title, and you need a key. Gee, you got some notes. I think that's valid input. Okay. That should have changed somebody. Okay, so I don't trust quantize. Okay, so I guess where we are, we've changed some things, but we're not propagating through correctly at this point. I think manual input just doesn't even monitor that, but I think it should have changed something. Yeah, we're disconnected from the proper input. Okay. So I think we've laid the seeds of what needs to happen, and tomorrow we'll tackle it. It feels close-ish. I don't know. It's going to be hard to get everything just right, but I know when we have to make it so if these ones with controls you can edit, that definitely should force the ID change, and we haven't done that. Yeah, it's not ready. I mean, it feels close, but it's not ready. All right, we'll pick up there tomorrow, Eastern time, 2 to 4:30, and UTC 6 to 8 p.m. And thanks for joining again, and hope I catch you in the future. Yeah, the ID was a good change. We'll have to make sure everybody's respecting it. I think we're closing in. Okay. Anyway, see you tomorrow, I hope. Bye bye.